Welcome to NASA headquarters. My name is Dwayne Brown with the Office of Communications here at NASA. This is part 2 of the New Horizons story connection with the Voyager 2 story. In panel 1, you heard about the mission to distant Pluto and the connection with the Voyager 2. Now we hear the behind-the-scenes stories. The stories that are inspiring and also bring the present, the past, and the future together. We'll take questions from our phone lines and from social media and get those questions in at #AskNASA. There's a lot of buzz about this mission. And for the students out there, these stories will certainly inspire you because one day you could really be a part, and you are a part right now, of the Pluto story. All of this information and more can be available at the website at www.nasa.gov/New Horizons. I enjoy this type of panel because I don't have to drive the bus. I can be a passenger. So what I'm going to do here is introduce the facilitator for this panel discussion. And I'm going to be very short with his introduction because his resume is just too extraordinary and too long, and it would take up too much time. So without further ado, I'm going to toss it to David Greenspoon, who is a senior scientist at the Planetary Science Institute and was also the Bloomberg NASA Library of Congress Chair in Astrobiology in 2012 through 2013. So David, you're driving.
All right. Thank you very much, Dwayne. And thank you all so much for coming out this afternoon. I'd like to say hello to everybody watching on NASA TV, and a special big hello to anybody watching live from the Burning Man Festival, which is going on right now. And you know, I'm sure you're all having a great time out there in Black Rock City. I hope you are. But I got to tell you that being a young scientist at the Jet Propulsion Laboratory during a Voyager encounter with one of the planets of the outer solar system. Now that was a party and a mind-blowing experience, and one that just is unforgettable and has stuck with and changed all of us who had the good fortune of being part of that. All of the panelists here this afternoon with me, we all got to know each other as young scientists during the time that Voyager was traveling through the outer solar system. And we are here to share a little bit of what that experience was like and how that experience has informed us both scientifically and personally as we approach the New Horizons encounter with Pluto next year. Now, the thing about the outer solar system is that the missions take a long time. Just all planetary missions take a long time, the planning, the execution, the data analysis afterwards. But with the outer solar system, you have a lot of travel time. So these are, you know, just the travel time to get out there. It takes years to get out to the distant planets. And so these are long-term missions, and you age, you go through things, your life progresses during these missions, and especially with something like Voyager, where there were several encounters separated by many years, encounters that were brief frenzies of activity and excitement, separated by the more quiet, distant years while the spacecraft was navigating the isolation of space, getting ready for the next encounter. And we all, I think, had this feeling of sort of traveling through our lives as Voyager traveled through the outer solar system. Personally, for me, Voyager was launched in 1977, the year I graduated high school. And in 1979, I was an undergraduate research assistant for the Voyager encounter, I think the coolest summer job anybody ever had at JPL, working with the imaging team during the Jupiter encounter of Voyager. By Uranus in 1986, I was a grad student working at the mission, and by Neptune, which we're really here to talk about, I was there as a postdoc. So these encounters were, of course, they were scientific bonanzas, but they were also gatherings of people who had gotten to know each other over the years, and so they also took on the feeling of family reunions. And you know, some people weren't with us any longer by Neptune, who had been with us at Jupiter. There was a personal aspect. Relationships formed, marriages, people had babies. And so there was this really growing sense of a family gathering at each of these encounters, in addition to the scientific excitement of the encounter. So I'm going to set the stage here by showing you a few semi-embarrassing snapshots of all of us at that time, the time of Voyager, and then I want to introduce my wonderful panelists here, and we'll hear their perspectives both on Voyager and on New Horizons, and we'll sort of time travel through the intervening 25 years. So this first picture is summer 1979, the Voyager imaging team. When as I mentioned, I was an undergraduate assistant, and I'm in the back there, the fourth from the right in the back row. And as you can see, I was learning a lot about science, but I had not yet understood the concept of haircutting and barbers at that time. Hey, look, it was the 70s, you know, what can I say? But I was there as a research assistant, undergraduate research assistant, hired by Carl Sagan, and mentored by all of these other wonderful scientists. You can see I'm standing there next to Steve Squires, who, Chris Squires is a bass player, Steve Squires, who is of Mars rover fame, and all these other faces are sort of our, you know, were like gods to us, these famous scientists then. And moving right along, the next picture, I believe, is a snapshot from the Neptune encounter. As you can see, I'd gotten a little bit more handle on my styling. And I'm there with Dr. Nick Schneider, who is now a professor of planetary science at the University of Colorado, and Dr. John Spencer, who's one of the panelists you'll meet here in a minute this afternoon. And we're pointing at Neptune as Voyager is at Neptune, and we were all grad school buddies who were just amazed to find ourselves in the company of these senior scientists getting to work on Voyager at Neptune. The next picture shows Jeff Moore, who's another of our panelists, and John Spencer and myself with a few of the other scientists doing what we did a lot of during those encounters, which is staring in wonder at a screen when the new pictures from, in this case, I believe it was Triton, were coming down for the first time, and we were laying our eyes on these new bodies, these new places, these worlds that previous to that had just been these dots and telescopic, blurry bodies that we would wonder about, and we were for the first time able to go, so that's what that is. And we're really just moments of discovery that we'll never forget. The next slide shows you one thing you have to realize is that celestial dynamics does not work on human time, it works on solar system time. So there were many nights when we were up all night getting the data down, and things got a little bit giddy. And here we are at the end, I think, of one of those long nights in a conference room. By the way, in the foreground is Dr. Paul Schenck, who's one of the people who's done these amazing movies that you've all seen, including one I think that we just saw in the last hour of putting together the images of Triton and other bodies into beautiful movie sequences to help facilitate our imagination. The next slide shows you the first of our panelists I want to introduce this afternoon. As you can see, we all had a little bit more hair back then. And Dr. John Spencer, here to my far right, is an institute scientist at the Southwest Research Institute. And at Voyager Neptune, during the time of this picture, he was a postdoc, a young hirsute postdoc. And I asked everybody to tell me what they remember about Voyager Neptune. And I won't tell you most of what they said because you're going to hear about it this afternoon. But John wrote to me, I mostly remember a lot of gazing awestruck at TV screens. And we certainly did a lot of that. But John's selling himself short. He helped at that time with some of the initial geological mapping of Triton. And he participated in a lot of the general science discussions about what it all meant, and started thinking a lot about volatile migration, by which we mean what happens to the gases and the solid surfaces, the ices, how they move around on a cold planet like that. And from those discussions, John developed models of Triton, which are still considered the important models that everybody uses, and which are also very applicable to Pluto. And I think that work that he did at Neptune and Triton led directly to the work that he's now doing on the New Horizons team. John is an expert on the moons of the outer planets. He's worked on a lot of spacecraft teams. I won't tell you all of it now, but in particular, he's currently working on the Cassini-Saturn orbiter, mapping the temperatures of Saturn's moons. And John discovered the thermal anomaly at the south pole of Enceladus, which was the key to discovering the ice eruptions on Saturn's moons, Enceladus. And he's made a lot of other cool discoveries, which you'll just have to wait to hear about. On New Horizons, he'll be coordinating the search for flyby targets beyond Pluto, or he is coordinating that search. The hope that New Horizons, after Pluto, can visit more bodies in the Kuiper Belt depends, of course, on finding those bodies. And John has been leading the charge, and we're confident that he will find us a good place to go after Pluto. There's more to say about John, but I want to move on and introduce the rest of the panelists so you can hear what they have to say. So sitting next to me here is another fine scientist and my good old friend, Dr. Jeff Moore. Jeff is a research scientist at the NASA Ames Research Center. And in this next picture, you can see him during the Voyager Neptune and Triton encounter, along with John and myself. Jeff is the one on the left there. And he was actually in his last year in grad school at ASU, Arizona State. And he managed to get invited to participate in the Neptune encounter. And actually, Jeff and I drove down together from San Francisco on Highway 1, and I remember us as young nerdy scientists sort of calculating our velocity and when we would reach Pasadena and calculating the spacecraft's velocity and make sure that we'd get there before the spacecraft got to Neptune and everything. Anyways, we did, and we had a great time there. Jeff also participated in a lot of the real-time first discussions of what formed the landscapes of Triton and a lot of that excitement of closest approach to Triton. And he began a discussion there, among other things, with John Spencer that led to the two of them writing a paper on the migration of volatiles on Triton, which a hypothesis that they called Koyanis Moyu. Maybe we'll let Jeff tell us more about that. And again, this work led directly to his work now on the New Horizons team, where he is the imaging node leader. And I'm sure he can tell you more about what that entails on New Horizons. Sitting next to me on my other side is Dr. Bonnie Barati. Bonnie is a principal scientist at the Jet Propulsion Laboratory, where all this excitement first went down. Here is a picture in the middle. You can see Bonnie as a postdoc during the time of Voyager Neptune. And there she was working on the photopolarimeter team. And again, that work helped establish her in her career, where in the interim time, she has had leadership positions on many NASA missions and many NASA advisory panels. Bonnie's the author of over 200 scientific papers, and she was awarded a National Exceptional Achievement Medal. I could go on, but and she has an asteroid named after her. But and currently she leads the planning effort for Icy Moons on the Cassini mission. But on the New Horizons mission to Pluto, Bonnie is, she's a member of the geology, geophysics, and imaging team, but in particular, she's the chief of photometry on the mission. Photometry means it's what we use to understand the nature of surfaces by the way they scatter light. And that is Bonnie's expertise that she's applied to so many places in the solar system, and now she's going to get to do it at Pluto. Finally, on the far left, we have Fran Bagenau. Fran's a professor of astrophysical and planetary sciences at the University of Colorado in Boulder. And at the time of New Horizons at Neptune Triton, here you can see a picture of fresh-faced Fran at New Horizons. And she
Voyager.
I'm sorry. We'll get to New Horizons. So many missions, so little time.
Voyager.
At the time, thank you. At the time of Voyager at Neptune Triton, she had just started as a new faculty member at the University of Colorado. In fact, she told me she was teaching her first class then. And she was working for Voyager on plasma science. That is, looking at how the gas coming from the atmospheres of the satellites interacts with Neptune's magnetic field. And in fact, on New Horizons, she will be leading the plasma and particles group and looking at how the solar wind interacts with Pluto's escaping atmosphere. So that's who they all are as scientists. And now I'd like to have you get to know them as people a little bit as well. So I'm going to start off with a question relating the experience of Voyager with what we sort of expect for the experience of New Horizons. Now, in NASA, with all these different kinds of planetary missions that we've all been involved in since Voyager, there are a lot of different kinds of missions. We do orbiters, we do rovers, we do entry probes, but there's a particular experience to a flyby mission. New Horizons will be a flyby, the first encounter with a new planet, and it all happens pretty quickly. You can't stop. You have, like in The Wizard of Oz, as the wizard said to Dorothy, I don't know how to stop it. I've got to keep going. So you only get, or sorry, as as a great rapper once said, you only get one shot. So so we have to do this right, and it all happens really quickly. And what I want to ask you guys, having been through it with Voyager, having been through repeated flybys, can you describe that experience? What is it about a flyby that's different from another kind of mission? Not just scientifically, but emotionally. And how does that differ? Tell us something about your experience with Voyager and how that maybe prepares you for what we're expecting at New Horizons. John, you want to start off?
Sure. Well, as you say, flybys are very intense. Particularly when, as often with flybys, it's the first time you've been to that place, and you don't know what to expect. You're trying to imagine, but you can't possibly imagine what you're going to see, and then it all happens so fast, and you're just blown away, and you're sort of dizzy for a long time afterwards. I remember with the Neptune flyby being up at 3 o'clock in the morning, and the pictures were coming down, and every picture was just utterly unbelievable, the level of detail we were seeing on Triton, this world that we'd had in our heads as just a point of light for a decade or more, depending how long we'd been thinking about it. And suddenly it's this world, and it's got an atmosphere, and we discovered the atmosphere that night. Just you could see these layers of haze off the edge of the disk. We saw this completely bizarre surface, and I remember thinking, this is like Mars. This is a world as complex as Mars that we've been studying for decades and have gradually got into our head over this series of missions. And we just get this one glimpse at it, and it's gone. And we're just going to spend the rest of our lives figuring out what that all means in that one glimpse. And I remember being, we were up all night, and we crawled under a desk or something to get a couple of hours sleep, and then going with you to a coffee shop in the morning and just sort of staring bleary-eyed at each other going, oh, wow, that was intense. And,
sounds like grad school, only more so.
That it's a once-in-a-lifetime thing. It's a once-in-the-human lifetime thing that you get to do that for the first time, and we're going to get to do that again at Pluto, and it's really been the first time since then we've had that kind of intense experience.
You know, I'm going to beg to differ with you, because I think that the people out there are going to have this experience again and again. When we left Neptune, I remember this feeling that, oh my golly, we were so privileged to be involved, but the poor next generation, they're not going to have this experience. And I think we're completely wrong there. I think that there will be not only Pluto and the next Kuiper Belt, whatever it is that we will fly by, but there will be many more. There's a whole world out there. I mean, just think about the Rosetta observations of that little comet that it's just found. You know, the rubber ducky, because I can't pronounce it, its proper name. There are going to be more and more and more of these. I think we're wrong to say that we were special, we were the only ones to have a flyby of a new object.
Yeah,
It'll
well,
keep
I
going.
mean, certainly new discovery has been a continuous process through our lives. I mean, Titan, you know, the Huygens probe at Titan, there have been a lot of firsts.
Yeah.
But a flyby is a kind of an unusual. So you're absolutely right. But I'm trying to also prepare people for the experience of this by like talking what's a flyby like. So, but I think we shouldn't oversell the fact that other people don't get to participate in amazing discoveries.
John did bring up an important point about the expectation of what you might see. I remember in the months before we approached Triton, there were like 2 different plans, Plan A and Plan B, for whether Triton was the size of Europa or Triton was the size of Ganymede, which is like 1.5 times the size of Europa. So there was a big plan to mosaic a big moon, and a smaller plan to mosaic a small moon. And there was a question whether Triton would have an extremely dense atmosphere like Titan that you couldn't see through, or would it have a clear atmosphere. There was a popular theory at the time that Triton might have large seas of nitrogen on the surface. And so there were all these great expectations, and to some extent, the vast range of them simply showed that we really didn't know anything until we got there, and the whole idea of picking the small target versus the large target was something people only knew in the last week before the encounter, and the idea it was going to be bright and not dark. All these basic things were like mysterious, and the expectation and the anticipation of it was very intense. And so I am seeing, and you can see in papers which are being published this year, that same sort of intensity of speculation and diversity of ideas of what we might see in the Pluto system.
I think in many ways, an encounter is almost like giving birth, because you have, in your, first of all, you have no control over the time. It's going to come no matter what. And, you go from just an idea in your mind to a whole new person or a whole new world.
And you don't get a lot of sleep.
That's also true, yes. And here's actually a T-shirt from all three of my children were born during the Voyager mission, and here's a little shirt that I bought for my 6-year-old then at the time, from the encounter, the Neptune encounter.
Doesn't still fit.
No, he's grown.
Well, let me move on to a question about the change in technology since Voyager, and how that maybe will change our experience of a flyby, and particularly the New Horizons flyby. Of course, we didn't have the World Wide Web back then, which is, I know, hard for some of you folks to imagine, but it's true. So every experience carries much more immediacy, and that helps us get information out to the public, for one thing, really quickly. And yet the New Horizons spacecraft is so optimized for size, it actually has a relatively small antenna, and therefore it takes a while for all the information to get back. So there's a sense of more immediacy, but also a sense where things are going to be more drawn out than Voyager because of necessity and of just the efficiency of that spacecraft. It will take longer. There'll be there'll be months while information's coming back.
Well, to use a metaphor that was used in the previous press conference, like having a Christmas present under the tree. Well, in fact, we're going to have new Christmas presents under the tree for months after the encounter. Some of the most important things that will really change our view of, for instance, the geology of Pluto, we really won't have in hand until many months after the encounter, like 6 months after the encounter. So it's going to be the gift that keeps on giving.
Yeah, well, so that's my question. Given all this, how do you think the New Horizons flyby will differ from the Neptune flyby? And in terms of both the experience of the team members and the experience of the public following along. And Jeff has already made the analogy of an extended series of Christmas mornings. Any other thoughts about that?
Well, I remember at Triton, we were frustrated in a way. We saw these beautiful color images, and we see, oh, there's blue stuff over here, and that area is kind of orange, and it's beige down here. And we knew from the observations taken from Earth that Triton has this wonderful mix of different frosts on the surface, nitrogen and methane and carbon dioxide and so on. And Voyager took these beautiful color pictures, but we didn't know which was the nitrogen, which was the carbon dioxide, because Voyager did not have the instrumentation to allow us to determine those things. Something we're very much looking forward to on New Horizons is that we have an infrared spectrometer that is going to tell us in exquisite detail what all those little bits of the surface, which we know even from those very blurry Hubble images, are very different from each other, what each of those little bits is made of. And that's going to be a huge advance in our understanding over what we were able to do at Voyager.
Fran, you have any thoughts about changing technology?
I think the biggest change is indeed the technology. And, I hate to be one of those old guys, but back at Jupiter, we were using punch cards and mag tapes, and then by the time we got to Neptune, yes, everything was on those TV screens, but those TV screens were novel. I mean, that was amazing to be able to analyze data on actual computers that you could fit in a room, let alone put it on your desk. And so big changes in technology just over the time, from those 12 years from Jupiter through to Neptune. And of course, there wasn't a World Wide Web, but everything was done with very primitive technology. And I was just amazed, though, that when we went to the press conference at the end of the Voyager Neptune encounter, there was this fantastic movie that was shown flying over Triton. And you can go to YouTube, you can see it. The flight over Triton is amazing. And I was just totally blown away that NASA could put together, the people at JPL could put together in a few days this flight from a few images. And it was that was mind-blowing.
That was really
to
Randy
see
Kirk's
that.
work. Yeah.
Now we expect that kind of thing.
Now we expect it.
And we can do it ourselves also.
Yes, exactly.
Yeah.
But I think that this
Any
issue...
child could do it on their computer now.
Right, yeah.
I could do it better probably than
And what happened, though, was that it came out over 3 or 4 days. I think that this is going to be very different for New Horizons. The time delay that we're talking about here, data coming in bit by bit over months and months, is very different. But I think the point that Alan made, that these data will be made available to the public immediately, is very, very different, very, very different. You know, we were a bit of an elitist small crew in the old days of Voyager, whereas I think New Horizons is much more inclusive in bringing people in and allowing them to play with the data and see what they see there and interpret it and understand it.
Yeah, so both the attitudes
culture
and the
has
technology
changed.
have changed
Yeah.
in terms of transparency and
Exactly.
immediacy. Yeah,
Absolutely.
yeah, that's really
Yeah,
nice.
I mean, the data belong to everybody. It's everybody's data.
Yep, you paid for it, you get to play too. All right, well, this is now I want to talk about sort of scientific careers and how reflecting over this time interval since Voyager, you know, what thoughts that brings up. We all participated in Voyager as young scientists just starting our careers and assisting and watching the senior scientists on the mission. And I just remember thinking those senior scientists were, you know, I was in awe of them. They seemed like they knew everything. And now we're senior scientists and we don't know everything. So,
Well, they were smarter than we were.
well, that's what I'm asking. Has scientists gotten dumber or were they faking it? No, but no, I mean,
we know now.
part of the poignancy of the Neptune encounter was the sense that not only had Voyager finally come to the end of its amazing run, but not knowing if we would ever, in our lifetimes, again send a spaceship that far out into the outer solar system. And yet here we are 25 years later, and we're reaching another new world even farther out than Voyager did. So at that time, would you have ever predicted that in your lifetime you not only helped to see, but helped to manifest a Pluto mission? And how does that, you know, when you think now of those senior scientists and yourself in the role that you're playing, how does that happen? How do you go from someone who's being a mentor to somebody who's mentoring young scientists? Anybody?
I know, I still think that those guys are the gods and we're still really just the kids, and the fact we're actually as old as they were then is something that I haven't really internalized.
Sobering.
Yeah. I think one thing that I really learned from the encounter was, and I think this gets back to your question, you know, didn't they know everything? No, scientists don't agree on stuff. And you know, this is in fact what propels science. It's because we disagree and we have different theories that propels more data to be collected and for us to finally get at the truth of the moment. And this is what I really learned. There were disagreements on the teams and there was some, you know, friendly fighting, and you know, that just, you know, it encouraged people to learn more and do more. That's what I think I learned from the encounter.
We were actually starting to work on a Pluto mission about the time. There was a scientific conference that we had in the summer of that year, where there was a presentation on presentations on Pluto. We're starting to work on that. Alan Stern was recruiting and galvanizing a group of people to work on Pluto, and so we were starting to think. I actually remember thinking, Voyager's over, now what do we do? This is about the end of it, isn't it? Where do we go now? I'm about to give up. And we didn't think that there would be more missions. I mean, there was Galileo and a sort of smell of Cassini on the horizons, but the idea that we would have multiple missions and keep going was very hard. I think that really what we have to think about now is that we have to take on those roles of trying to get the next missions going, the missions to go back to Titan Titan, the mission to go to Europa, the missions to go back to Venus, your planet. I'd love to go back. Doesn't have a magnetic field, but let's go back to Venus and things like that. Many places, Uranus and Neptune, let's go back there. There are plenty of places, and I think our job now is to try and get those missions going and off the ground so that the next generation can take over and be there doing the work down the road 25 years from now.
Talk about mentoring. Mentoring seems to be something that comes at least gradually, if not naturally, because it takes so long, it has taken so long from the last major encounter 25 years ago to now that as we pass through our careers, you know, we reach a point where we begin to take on graduate students and postdocs. We begin to show them the ropes and exchange ideas and form intellectual salons that we keep with each other. And we develop a rapport not only amongst ourselves, but amongst the younger generation. And they have great ideas. We bounce ideas off of each other. And so it seems almost naturally, especially if it takes 25 years from one major encounter to the next, that you have, as a senior scientist, acquired a relationship with the younger generation, and it's easy to say, hey, let's get these guys involved. Let's ask them to work on this. You know, they have lots of great ideas. They're full of energy. You know, let's bring everybody on board. It didn't seem like you had to put a lot of deep thought on how you were going to do it. It just came naturally.
I mean, one striking thing is that a fair number of those people that were the senior scientists at Voyager Neptune are still involved and still some of the key people working in our field. So I don't know what that means. Maybe it's good for your health, planetary encounters, or it's just good to be engaged in a long-term endeavor. I got a question that maybe, Bonnie, you'd take a first crack at, and then anybody else could chime in. What was the biggest surprise for you about Voyager at Neptune and at Triton? And what would surprise you the most about the Pluto system?
Okay, I would say the biggest surprise at Neptune was the plumes on Triton. Now, here is this really, very cold, so cold that it's about minus 400 degrees Fahrenheit. I mean, it gets about 1/10 of 1% of the radiation that the Earth gets, solar radiation. And here, when we approached, we saw these polar caps that were sublimating away, disappearing, and these plumes were spouting out this dark material. That was totally unexpected. Nobody predicted this. And this is what I would be surprised at Pluto if we didn't see something like that. Because we have been watching Pluto as a little pinpoint of light in the sky that we see from a telescope. We've been looking at that for really decades now. And it looks like the frost patterns are changing. And I think the polar caps are sublimating away, and we're going to see plumes. I think I'd be surprised if we did not see the same types of plumes on Pluto that we saw on Triton.
I like that. I hope you're right.
I think so too.
Anybody else surprises from Neptune, Triton, and what would surprise you at Pluto?
The most surprising thing to me was the so-called cantaloupe terrain. It was a whole region of Triton which looked like nothing we'd ever seen anyplace else in the solar system, and we had just come off 10 years of exploration of the outer solar system and its satellites with Voyagers 1 and 2, and so we thought we'd seen at least a little bit of everything, but no, we hadn't. It really was something, and now for something completely different, cantaloupe terrain. And I guess the one thing I would be truly surprised if we got to Pluto was that we weren't truly surprised.
Well, I'll be truly surprised if we see New York.
Really setting the bar there, friend. Well, speaking of the dangerous art of prediction, I think it's clear that really nobody is any good at predicting the future. I mean, you think of the movie 2001: A Space Odyssey. It was 33 years from the making of that movie until the year 2001. And look how far off the mark that future was. I mean, it's not even here yet, right? Here we are, 2014. But I want you all to take a stab at it anyways, or any among you who dare. In another 25 years from now, what will we be doing in the solar system? And of course, we'll all gather here together in this room and watch this tape and wince at ourselves. Any thoughts? 25 years from now?
I want to go back to Triton, damn it.
Yes. Oh, I'm sorry. Yes.
Titan or Triton?
That's
Triton.
Triton.
Yes. I want that glimpse, that wonderful glimpse we got 25 years ago, not to be the last we see of Triton in our lifetimes. I have this emotional connection to Neptune. It's a beautiful planet. It looks kind of like the Earth. It's blue with white clouds. It's an incredibly rich system with all these amazing phenomena on Triton that we didn't get to really understand with even the amazing discoveries of Voyager. And so I don't know if we'll get back in 25 years, but I'm hoping we get back there someday. But there's just so many amazing places in the outer solar system that we can explore. And it's hard getting to the outer solar system. It takes a lot of time, as we've seen here. It takes a lot of technology, but we can do this. And I really hope that we're going to go back and follow up on some of the amazing discoveries that we've made.
Okay, John's predicting a Neptune orbiter. You all heard it here. Jeff?
Well, of course, I'm very excited about the possibility that we'll be soon going back to Europa and understanding Europa, which is this amazing ice world. It's basically a global ocean that has about 10 or 15 miles of a global ice pack over maybe a 50 or 60 mile deep ocean. It's probably one of the best candidates, if not the best candidate in the solar system for extant life, if it's any place other than on the Earth. And I think the opportunity to learn about its surface has to be, something I'm looking forward to, and I think many people I feel are looking forward to. Then after that, I'd love to see Titan again. Titan, is such an amazing world, and you really want. It's so Earth-like on its surface as far as the geological processes which operate there. You really want to go back and study it in much more detail than we've been able to do with Cassini.
Thank you. Any other thoughts about 25 years from now?
Well, I think we have to focus on habitable zones, areas where life could potentially exist. So that's obviously Mars, that's obvious. But there's Enceladus, Europa, and Titan. And I think in many respects, I agree with Jeff that Titan is really, the most Earth-like. It's the only place where there's currently standing liquid. There are all sorts of, drainage patterns and clouds and seasons. It looks very
seas of liquid methane.
Exactly. So
bigger than the Great Lakes.
Yeah, it would be a great place to go.
Aren't there models of Pluto that have a liquid interior?
Correct.
Yes, you have a liquid interior, but probably many of the ice worlds that are at least the size of the Earth's moon or larger probably even today have a liquid layer someplace deep inside the planet. Even the so-called boring moon Callisto, which is a huge moon the size of the planet Mercury that orbits Jupiter, apparently has a small liquid layer. So liquid layers alone are not that uncommon.
So I'm the only one here who's going to advocate for life on Pluto? Fran, go ahead.
No, I'm not. Yes, you are the only one going to advocate for life on Pluto. I want to push your planet, Venus. I'm not interested in Venus because it doesn't have a magnetic field. I study magnetic fields. But personally, I actually think I would like to go back to our sister planet. It's our nearest neighbor. It's the one that is, boy, it has a different atmosphere, totally different atmosphere. And if we want to study atmospheres and atmospheric change, which I think here on Earth we do want to know and understand, Venus is one of the places we should go. Huge technological challenge, very, very difficult. We'll need those RTGs to go there to cool down the spacecraft so we can get into this very hot place. Let's go to our sister planet as well. These are all very exciting places.
Yeah,
of course, I'd love to go to these places.
It's a place the size of the Earth, yet it has a completely radically different geology, which we really don't understand very well.
Why?
Yeah.
Why?
Well, you're not going to hear me argue with that at all. Clearly, there's a lot of exploring left to do. We're just scratching the surface of the solar system. I haven't heard anybody advocate yet, for amongst at least this afternoon, for the next Pluto mission after New Horizons. But I guess I would point out that before Voyager at Triton, you wouldn't have thought about the next mission to Triton. It's once you discover what these places are like that you start thinking about the next step. And so we'll wait and see what Pluto has in store for us. We could keep talking amongst ourselves for hours. I can tell we're just getting going with the stories, but I feel like we ought to involve also the audience, both here in the room and on social media, in the conversation. So what I'd like to do now is to turn it back over to Dwayne, and he'll moderate the Q&A portion of this.
Thank you, David. Okay, yeah, we're going to start with social media. In the audience, I see a lot of new faces, and so I'm going to open it up to the floor to anyone visiting us or involved in science or in the schools that are here, even the NASA employees. feel free to wait for the mic and ask your question, but we're going to go to social media. And J.D. Harrington, you've got the con here, sir. What's going on in the Twitter world?
Well, thank you, Dwayne. Yes, we do have a few questions. The first one is, how will the New Horizons pictures of Pluto compare to the Voyager 2 flyby pictures of Triton?
I think Jeff or John, but either one of you guys.
They'll be over an order of magnitude better. They'll be more than 10 times better than the best pictures of Triton taken by Voyager 2.
I think one measure of that is the highest resolution camera, the main camera on Voyager, was about 0.6, 0.7 megapixels in modern digital camera technology, and it took these fabulous pictures. We have the equivalent of a 25 megapixel color camera on New Horizons, and so that gives you an idea of the level of detail we're going to see in these pictures. It's going to be amazing.
And we're flying 4 times closer.
Excellent.
Something to look forward to.
Our next question says, will New Horizons be able to gather any high-res data on Pluto's other moons?
Go ahead, John.
Yeah. Indeed, we discovered the 2 moons, Nix and Hydra, just about at launch, so we've had plenty of time to plan our observations of those as we go past. We come fairly close to Hydra, and we come fairly close to Nix, and so we'll get our best pictures of Nix. We should have pictures of Nix that are a couple of hundred pixels across, something like that. Hydra we'll also get more distant pictures of. The 2 new moons, Styx and Kerberos, we'll be looking at, but from quite distant range, because we found them late enough that the encounter had mostly been sequenced at that point. But even those will get good enough pictures that we can tell their shapes and their sizes and their colors, and we're very much looking forward to that.
JD, we'll take one more. I'll see if we have any questions here in the audience, and then we'll begin to wrap up here. Give me one more.
Yes, stand by for just a moment. Here's a question about future. You talked about 25 years from now. What new technologies are needed for future outer planet missions? Better power sources, communications, rocket propulsion?
Fran or Bonnie?
All of those 3, those are the 3 biggies, right? Propulsion, communication, and power. Absolutely. Those are the big tough ones to do in the outer solar system. So we're very dependent on, as Jim Green described in the first section, we're very dependent on using our radioisotope thermoelectric generators, RTGs, to power our spacecraft in the outer solar system. And we very much depend on our DOE colleagues here in helping us. A great partnership between DOE and NASA to make this happen. And we really are dependent on this to be able to get to the outer solar system. One hopes that maybe communication can become more efficient, but you're just fighting distance. And the fact that we use electromagnetic waves to communicate, and so we have a limitation of the forces of nature that tell us this is how light and electromagnetic radiation works, radio works. I don't think we can move to anything else. We're stuck with that. We don't have warp drive. You know, it'd be nice to have warp drive, but we don't yet, and so we're kind of limited with how we do things.
Although NASA has investigated things like using lasers for communication, which
right.
if they worked out,
Optical.
would actually,
I think we've got a toughie there trying to talk with Triton and Pluto with lasers, but you know, we have to think about how to move forward. I think one of the very exciting things that I've noticed is the ability to do more with less. So if we think about how we've moved with New Horizons to these very lightweight, low power systems, and I think we're just going in that direction more and more as we design instruments and spacecraft. So I think doing more with less is really the way we're going, rather than we can expect radically new technologies. But who knows, you know, could be completely wrong.
Yeah. There are certainly some technologies that have been talked about for a long time that can help us with the outer solar system, one of which is aerocapture. If we're
good one.
Going to go back to Titan, maybe going to orbit around Titan, we can use Titan's extended atmosphere to slow us down and take us into orbit, or lose a lot of the energy, the speed it took us to get there. So people are working on these. This might also be a way we could get back to Neptune if we can skim the atmosphere of Neptune or Uranus if we're going back there to slow us down. And so people are working all these angles, trying to figure out which are the most practical to develop further and fly to get us to these amazing places.
I mean, just looking at the difference in the New Horizons spacecraft compared to the Voyager spacecraft, you really see this doing more with less. And it's hard for us to extrapolate that completely 25 years into the future, but one can imagine we might have some very small, very fast, very capable spacecraft.
One thing I also want to mention is a very hot topic is CubeSats. These are the small little things. And working with grad students at the University of Colorado, they've got really exciting ideas about sending a whole flotilla of little CubeSats out into the outer planets, exploring the magnetosphere of Jupiter, for example, and sending back data across a big volume of space, you know, with a mothership communicating back. These are great ideas that are coming out from the world out there.
Oh, we have a couple of questions from our audience. Let's take the young man, if he could stand up. Ask your question.
What made you so interested in the planets?
Wow. What made us so interested in the planets?
They're cool. They're cool.
We live on one.
They're fun. They're fun to go explore. You don't know what you're going to see.
You know, when I was about your age, they were sending the first missions to Mars and to Venus. And I was also really into science fiction and just fantasies about space. And the two kind of blended together in my mind, just like traveling through space and seeing new worlds. I just couldn't imagine anything cooler. And then I discovered that you could actually do that as a job when you grew up. It wasn't just something that you like sort of did for fun and saw in the movies. And so I couldn't imagine wanting to do anything else.
That's a very good answer. I can't do really better than that.
Yeah, it is science fiction come to life. We actually get to fly to other planets. I mean, it's unimaginable that we get to do these amazing things, that this nation gets to do these amazing things.
And it's funny, John used the phrase, we get to fly to other planets. Of course, we don't. We sit here and we send spacecraft. But it feels like we get to fly to other planets. When you work with these spacecraft, you start to really identify with them, and you almost feel like you've been, like with Voyager, it felt like we were going to Jupiter and Saturn and Neptune, and now it feels like we're going to Pluto. So even though we're just sending spacecraft, it's very real, and it really does feel like you're traveling to these places.
But it's even better because they have eyes that can see in the infrared and the ultraviolet and detect all the magnetic fields and the particles. So it's actually better than being there. And you don't have to worry about wearing spacesuits. So.
Yeah, we have superhuman bionic spacecraft.
Yeah, exactly.
That's right.
Yeah, I know for me, I was captivated by looking at the planets through a little telescope in my backyard as a kid, and I remember my first view of Saturn, and there it was with, you know, you could see the rings. It looked just like those pictures in the books, and it's just enthralled me ever since, and it always will.
Yes, sir.
So I was thinking there perhaps is another connection between New Horizons' flyby of Pluto and the Voyager flyby of the Neptune system, and that's really with Triton. And that is, do you think Triton is potentially a captured Kuiper Belt object and more akin to what Pluto might look like than anything else? And how would that fit in our ideas of the origin and evolution of our solar system?
Anybody?
Yeah,
Yeah.
I can
Go ahead, John.
try. I remember at the Neptune encounter thinking, boy, this is the closest, this is almost like seeing Pluto, because we do believe, I think most scientists now believe that that Triton and Pluto were both formed in the same part of the solar system, and Triton came close to Neptune, got captured, whereas Pluto continued in its own way around the solar system. They are siblings. And they have so much in common in terms of their composition, their size, their density. And we were very aware during the whole Voyager mission that we got to go all these places that we then knew about in the outer solar system, except Pluto. But at least we got to see Triton, which was the next best thing to getting to Pluto itself. And so it's a very big question that we're fascinated to learn the answer to is Triton going to have this sorry, is Pluto going to have this very exotic, weird, cantaloupe-y, lakey, plumy surface that Triton has? Or is it going to look like a much quieter, less active world? And we don't know why Triton looks the way it does. And when we see Pluto and we see whether it has those similar kind of patterns, we will learn a lot, not just about Pluto, but about Triton. So we'll be returning the favor, and Pluto will then be telling us about Triton as well.
Yeah.
Okay, we're going to take one more question here, and then we're going to take one last question from social media. And ladies and gentlemen here and in the audience, I think you're going to recognize the name on the social media question. Good, sir.
How excited are you to see the first images on a high-definition TV as opposed to, or high-definition computer screen as opposed to a TV? And then can you tell us about some of the lessons you learned from the earlier flybys that you're now applying to the New Horizons flyby? Bonnie?
Well, the images are a lot better, that we're getting now. So that's pretty exciting. And, what lessons have we learned? I think, first of all, as was pointed out, to get as many people involved, get the younger generation involved, to welcome new ideas, to not be judgmental about crazy ideas that people may have. I mean, who would have predicted, plumes on Triton? But I think, to open up and also to communicate. We really want to communicate because we are supported by the taxpayers, and it's your data. It's not our data. It's your data. So we want to make that clear that this is the heritage of the American people, and we want to share it.
JD, who do we have?
Well, here's a question from someone who's traveled the universe, at least on television. William Shatner from Star Trek fame asks, what can we do to get Pluto's planetary status back? There can't be just 8 planets on our solar system.
Well, a question from Captain Kirk. The thing about the whole planet debate, it was only necessary because we've learned amazing things about Pluto. As Alan Stern said earlier, we're exploring this new realm of the solar system that we haven't explored before, the realm of dwarf planets. And dwarf planets are this amazing new kind of body that, that we're about to learn a lot more about than we have. Take us into orbit, Captain. Beam us up to Pluto. The whole thing, as silly as it is, comes down to whether you think a dwarf planet is a planet or not. And that's kind of semantic.
Dwarf people are people.
Right.
Dwarf planets are planets.
Right.
Come on.
So, I almost feel like we don't need to dignify ourselves with that because it's actually rather silly. We all agree that this is one of the most fascinating places to explore. We all agree that Pluto is a dwarf planet, which is a new class of object that we're going to visit. And whether you add that a dwarf planet is not a planet, I don't know. To me, that's personally, I just think it's kind of silly. Any other thoughts?
Actually, it's interesting that William Shatner should ask the question because there's a metaphor known as the Star Trek bridge monitor effect, in which Captain Kirk, they approach an object, it appears on the bridge screen. He doesn't turn to Mr. Spock and say, "Is that a planet?" It's immediately obvious when you see it. It's a planet. So that's
a good point.
Next summer,
if something looked like Pluto came up on Kirk's view screen, he wouldn't say, "I'm sorry, Spock, take us somewhere else. That's a dwarf planet." He'd say, "That's a planet." So,
well, if you're an alien spaceship coming into the solar system, the only 4 planets you would see are Jupiter, Saturn, Uranus, and Neptune. The Earth, Mercury, Venus, and Pluto would all look like, kind of like rocks. So if you're going to demote Pluto, why not demote the other 3, smaller planets? So it really is quite arbitrary.
It is arbitrary, yes.
But I think the reason this question even comes up is because Pluto is something else. It's something different. It doesn't fit into our nice orderly scheme of the rest of the solar system. That's telling us that the fact that we have trouble classifying it, giving it a name, tells us that it's something weird and wonderful and new and exciting. It's not going to fit into our nice, neat categories. It's something completely new, and we can't wait to get there.
We better go check it out.
Let's do that.
All right. Well, actually, this is a great segue. Before I close out, I'm going to ask Dr. Alan Stern, the New Horizons Principal Investigator from Southwest Research Institute in Boulder, Colorado, to come to the podium. Dr. Stern.
Well, it's been a pleasure for all of us to begin to tell you the New Horizons story today and to start to involve you in this great mission of exploration. You know, New Horizons has so many aspects. It's about high tech, and it's about exploration. And as I said at the outset, it's also about a generational change. It's a handoff from Voyager exploring the middle zone of the solar system to New Horizons, going even farther and faster to explore Pluto and dwarf planets for the first time. And in this wonderful panel that David just ran, you had a chance to hear from people who, at the beginnings of their career, were young scientists taking part in cutting-edge exploration at the Neptune system in their 20s and early 30s. Scientists who had whole new worlds to explore. They were seeing them for the first time and applying all the technical skills in physics and chemistry and programming skills and other things that they had learned to make the most of all the ones and zeros, the data coming down from space. And then you've had a chance to hear what it's like 2.5 decades later as senior scientists to be a part of New Horizons, having a second chance to be on a mission of raw exploration like this. But one thing about planetary science and about space exploration is that it is truly generational, and it truly is not just about the machines and the technology, but also about the people. And just as we have heard from young scientists who have now become senior scientists, young people from the 1980s and 90s who started their careers exploring the giant planets and who are now in full bloom in their careers exploring Pluto and the Kuiper Belt for the first time. We also have with us today a set of young scientists who are the postdocs on New Horizons. They don't have as long a hair as the Voyager team did in the 80s, but they are at least as talented and every bit as energetic and as much excited by the chance to be a part of something larger than life like this as these scientists were at the start of their career. Ladies and gentlemen, I'd like to introduce to you another part of the Corps of Discovery. Meet the postdocs of New Horizons. Please stand up. And I'll close by posing a question. Yeah, you can sit down now. Think about the next 25 years and ask yourself, what missions will these scientists be principal investigator of in the 2040s? What will NASA in the United States and the world be doing to explore the universe then with these scientists at the helm? Thank you again, everyone. We've really enjoyed the afternoon, and we look forward to bringing you this encounter with Pluto next year. Good day.
Thank you, Alan, and thank you all for joining us today on our doubleheader about New Horizons 2015. Look out. Here we come, Pluto. Thanks for joining us.